Hello and welcome to lesson 1.3, the order of operations for Algebra 1. So I briefly discussed this last week as we were going through lesson 1.2 and how I will be teaching the order of operations this school year. Again, in the past, you might be used to an acronym such as PEMDAS, with a saying such as, "Please excuse my dear Aunt Sally," or something similar. You'll see as we go forward again, my switch is that now the order of operations begins with a G. So I teach it as GEMDAS, and that's explained in this first paragraph. So the first paragraph says, mathematicians have established an order of operations to evaluate an expression involving more than one operation. So again, operations are things like powers, multiplication, division, addition, subtraction. So if we have more than one operation, we follow the order of operations. Then it says you always start with operations in the grouping symbols. So that's why it's a G and not a P for parentheses. Now we're dealing with all grouping symbols. Could be brackets, could be parentheses, and so on. After grouping symbols, we move to our exponents and powers. Then multiplication and division from left to right, and then addition and subtraction from left to right. So before we go into example 1, I'm going to explain this diagram I drew here for the order of operations. What we want to remember is, again, for GEMDAS, we always start looking for grouping symbols. The grouping symbols tell us the math inside must be done first. Then once we've taken care of the math inside the grouping symbols, we move into our exponents or powers. Then multiplication and division, the reason I have it boxed in, is those can get done in the same step from left to right. So if we only have multiplication and division, we can do them in the same step. We just work left to right. Same with addition and subtraction. Addition and subtraction can be done in the same step as long as we go left to right. So we're going to look at some examples and just practice and get some refreshers on the order of operations. So example 1 asks us to evaluate the expression when x is equal to 4. So in both of these, A and B, we'll be plugging in a 4 for x. And remember, to evaluate means to solve or simplify. So in part A, we have 3 multiplied by x squared plus 1. So in this case, that would become 3 multiplied by 4 squared plus 1. We don't have any grouping symbols, so we start with the exponent or power of 4 squared. 4 squared is 16. I write down what I didn't use. So now I have 3 multiplied by 16 plus 1. Then we have multiplication and addition, so I need to multiply first. 3 times 16 is 48. And then 48 plus 1 gives us our final solution of 49. In B, we have 32 divided by x squared minus 1. So we're going to put a 4 in for x, so it becomes 32 divided by 4 squared minus 1. No grouping symbols, so I start with the exponent. 4 squared is 16. Bring down anything I didn't use, so 32 divided by 16 minus 1. Then 32 divided by 16 is 2, so it's 2 minus 1, and 2 minus 1 gives us our final answer of 1. So again, you'll see each step of the way, I just wrote down my information and brought down what I didn't use to the next step. In example 2, they want us again to evaluate the expression, but this time when x equals 3. So in A, we have 4 times x squared minus 8. So that's 4 times 3 to the second power minus 8. Start with our exponent, so 3 squared is 9. So this becomes 4 times 9 minus 8. 4 times 9 is 36. Multiply before subtraction. So we'd have 36, bring down the minus 8, and 36 minus 8 gives us our final answer of 28. And then in B, we have 27 divided by x squared plus 3. So in this case, no grouping symbols, so we start with the exponent. So 27 divided by 3 squared plus 3. 3 squared is 9. So then I bring down what I didn't use, and I have 27 divided by 9 plus 3. Now I need to take care of division before addition. So 27 divided by 9 is 3. I bring down the plus 3, so 3 plus 3 gives us a final answer of 6. So in example 1 and 2 here, we're evaluating, so solving or simplifying, for our expressions when we plug a certain value in for our variable. And then we follow GEMDAS for the order of operations to solve. Then, as I mentioned, with multiplication and division and addition and subtraction, we have what is called the left to right rule. So operations that have the same priority, meaning multiplication and division, or addition and subtraction, those are performed using the left to right rule, as we'll see here in example 3. So if my whole problem is multiplication and division, or addition and subtraction, we simply work left to right to solve it. So in 24, it's all subtraction. So I'm just going to go left to right. 24 minus 8 is 16. And then I'm left with 16 minus 6, which gives me a final answer of 10. In B, it's all multiplication and division, so I go left to right. 15 multiplied by 2 is 30. Then bring down the dividing by 6. 30 divided by 6 gives me my final answer of 5. And then in C, we have addition, division, and subtraction. So first, I have to take care of the division. So I bring down the 16 plus, and then 4 divided by 2 is 2, and bring down the minus 3. So then it becomes 16 plus 2 minus 3. Now it's all addition or subtraction, so we just solve it left to right. 16 plus 2 is 18. 18 minus 3 gives us 15. So this box at the bottom is just taking GEMDAS and putting it into 4 steps. So first you do the operations in grouping symbols. Then we evaluate powers and exponents, multiplication and division left to right, and then finally addition and subtraction left to right. Example 4 is looking at how we deal with simplifying and evaluating fractions. Now, what you want to remember is the fraction bar simply means divided. So if we have something in a fraction, it's going to eventually mean top divided by bottom. But to simplify, what you want to do is you simplify the top and the bottom first, just by using the order of operations on each separately. So on top, we have 7 times 4, and on bottom, 8 plus 7 squared minus 1. So on bottom, I can simplify starting with the 7 squared, which is 49. So on top, I have 7 times 4, which is 28. And on bottom, I have 8 plus 49 minus 1. So going left to right, that would be 8 plus 49 is 57, minus 1 is 56. So once we've done the math on top and bottom, then we can look at our fraction and see if the top and bottom can be simplified further by dividing them by the same factor. So 28 and 56 can both be divided by 28. So that would simplify to 1 over 2. If you didn't know to start with dividing by 28, you could start by dividing top and bottom by 2, and then checking again to see if that can be simplified further. In B, again, we want to first do the order of operations on top and bottom separate. So on top, it's just 24 times 3, which is 72. On bottom, we have 5 plus 3 squared minus 2. So I start with the 3 squared, which is 9. 5 plus 9 minus 2 is 12. So I have 72 over 12. Then both top and bottom can be divided by 12. So if I divide the top by 12, I get 6. The bottom by 12, I get 1. And 6 over 1 is the same as 6. And then example 6 is asking us to use the order of operations to simplify. And they're just giving us multiple operation expressions. We want to keep in mind GEMDAS and go from there. So looking at A, I have no grouping symbols. Then I check for exponents, no exponents. So now I can move into multiplication and division going left to right. So the first thing left to right that I get is division. So I'm going to bring down the 14 plus, 18 divided by 2 is 9, and then bring down the rest that I didn't use, multiply by 18 minus 7. Now I need to take care of my multiplication. So 9 times 18 is 162. So then we have 14 plus 162 minus 7. Work that left to right. 14 plus 162 minus 7 gives us 169. In B, I have grouping symbols, so I need to start there. So in B, I'm going to do the math inside, which is addition and subtraction. So I'm going left to right. 9 plus 33 is 42. Minus 6 gives me the 36. Then, because I did the math inside the parentheses disappear. So what I bring down is 36 divided by 6, and then I also have a 3 squared. So that 3 squared can be written as 9. So I took care of my exponent as well. Then I need to take care of division before subtraction. So 36 divided by 6 is 6, and 6 minus 9 is a negative 3. And then in part C, we have 2 different sets of grouping symbols. So I'm going to do the math in both first. 6 plus 3 is 9, so that first one just becomes 9 squared. Then on the right, we have 9 minus 10 divided by 5. So I have to do the division first, so that becomes 9 minus 2 in parentheses. Then 9 squared is 81. 9 minus 2 gives me 7. So now that I'm done with all the math inside the grouping symbols, they disappear. And then we're left with 81 plus 7, which is 89. Now, ignore the day 2 up here because we have a longer class. We're going to take care of all of 1.3 in one day. So our last set of notes, again, is just some extra practice refreshers on the order of operations. So our first 2 are evaluating. So we're going to plug in what the variables equal. So on A, we're plugging a 3 in for x. So we have 4 times 3 squared plus 3. Start with the exponent. 3 squared is 9. 4 times 9 plus 3. Multiply. 4 times 9 is 36. 36 plus 3 gives us 9. In B, we have 29 minus 4 times B. B is 6, so it's 29 minus 4 times 6. Start with our multiplication before subtraction. 4 times 6 is 24. So 29 minus 24. Ignore that 2 there. That's a mistake. It should just be the number 5. 29 minus 24 is 5. So our answer to B is simply 5. Moving down, example 2, part A. We're just simplifying. All addition or subtraction, so we use the left to right rule. 28 minus 7 is 21. 21 plus 4 is 25. In B, we have to take care of division first. So 9 divided by 3 gave me 3. Bring down what we didn't use and rewrite it. So 15 plus 3 minus 4. Now we can work it left to right. 15 plus 3 is 18. 18 minus 4 gives me 14. Now in C, we have a fraction, so we are going to simplify top and bottom separate. So in C, 5 times 3 on top is 15. On bottom, 13 plus 6 squared minus 4. 6 squared is 36, so it's 13 plus 36 minus 4, which simplifies to 15 over 45. Then 15 and 45 both can be divided by 15. So top and bottom divide by 15, and we're left with 1 over 3. In D, we have 2 sets of grouping symbols. We have brackets and we have parentheses. So we always start with the innermost set. So we have to start with the parentheses because they're inside the brackets. So in my parentheses, I have 4 cubed divided by 8. 4 cubed is 64. So if I rewrite that problem, taking care of the 4 cubed, it becomes inside the brackets, 22 minus parentheses, 64 divided by 8, and parenthesis, and bracket, and then that whole thing is multiplied by 3. So what I need to start with is 64 divided by 8. 64 divided by 8 is 8, and now that I took care of that set of parentheses, they went away. The brackets could stay as brackets, or they can turn into parentheses, and I still have 22 minus 8 inside that grouping symbol. So we got rid of this first set of grouping symbols, but we're still left with the one around the 22 and the 8. So then we have to do 22 minus 8, which is 14. And then we can finally multiply by the 3 at the end. So 14 times our 3 at the end gives us 42. Then our last example, example E. So in E, we have 10 minus, and the way this reads would be 2 multiplied by the quantity 3 squared plus 2, and then plus 8. So 2, and then in parentheses, we have 3 squared plus 2. So we need to take care of that 3 squared, which becomes 9. So this would be 10 minus 2, and then that's being multiplied by what's in the parentheses, 9 plus 2, and parentheses plus 8. So then we have to do the 9 plus 2 in parentheses. 9 plus 2 is 11. So this then becomes 10 minus 2 multiplied by 11 plus 8. Because a number next to parentheses in algebra means multiplication. Then we have subtraction, multiplication, and addition, so I need to multiply first. 2 times 11 is 22. Then it's all subtraction or addition, so I can work it left to right. 10 minus 22 is a negative 12. Plus 8 would move me back to a negative 4. So the most important thing today, as you're working through your practice problems and getting used to the order of operations, is again, be very careful about following this piece here and making sure that you're writing it out one step at a time so that you don't skip any steps or take an operation for granted.